Oceans are always moving. Beneath the surface, a vast network of currents churns. These currents are like rivers flowing across the globe. They carry warm water from the tropics to the poles. They also carry cold water from the poles to the tropics. Imagine a giant conveyor belt, silently circling the planet. This is what the ocean's currents are like. They are the lifeblood of our planet, regulating temperature and distributing nutrients. Without these currents, the Earth would be a very different place. Understanding ocean currents is crucial. They impact our climate, our weather, and the health of marine ecosystems. By learning about these powerful forces, we can better appreciate the delicate balance of our planet. Let's dive in and explore the wonders of the ocean's hidden highways. What makes these underwater rivers flow? How do these invisible forces shape the vast oceans? It's a combination of forces, each playing a crucial role in the grand scheme of oceanic movement. The sun, our life-giving star, plays a key role in this process. It heats the water at the equator more than at the poles, creating a significant temperature gradient. This temperature difference leads to density variations in the water, causing it to move. Wind is another powerful factor in this equation. As wind blows over the ocean surface, it drags the water along with it, creating ripples and waves that travel vast distances. This interaction between wind and water generates surface currents that flow in intricate patterns, influenced by the Earth's rotation, known as the Coriolis effect. Salinity, the saltiness of the water, also plays a significant part in this dynamic system. Saltier water is denser than fresh water, and this difference in density drives the movement of water masses. When water evaporates from the ocean surface, it leaves behind salt, increasing the salinity and density of the remaining water. This denser water sinks, creating deep ocean currents that flow beneath the surface, contributing to the global circulation of ocean water. The interplay of these forces, the sun's heat, the wind's push, and the salinity's pull, creates a complex and dynamic system of currents that constantly circulate around the globe, shaping our climate and marine ecosystems. Not all ocean currents are the same. They vary in depth, temperature, and speed. We can broadly categorize them into two types: surface currents and deep ocean currents. Surface currents, as their name suggests, flow near the ocean's surface. They are driven primarily by wind and are influenced by the Earth's rotation. These currents are relatively fast-moving and play a significant role in transporting heat from the tropics towards the poles. Deep ocean currents, on the other hand, flow far below the surface. They are driven by differences in water density, which is determined by temperature and salinity. These currents move much slower than surface currents, but they carry vast amounts of water around the globe. Some ocean currents are so large and powerful that they have their own names and are studied extensively by scientists. These currents are like the arteries of the ocean, transporting heat, nutrients, and marine life across vast distances. They play a crucial role in regulating the Earth's climate and supporting marine ecosystems. One such current is the Gulf Stream. This mighty current is one of the most well-known and studied ocean currents in the world. The Gulf Stream is a warm and swift Atlantic current. It is characterized by its powerful flow and significant impact on the climate of the regions it touches. It originates in the Gulf of Mexico, flows up the eastern coastline of North America, and then crosses the Atlantic Ocean towards Europe. This journey spans thousands of miles, making the Gulf Stream a major player in the global ocean circulation system. This current acts like a giant radiator, bringing warmth to Western Europe and moderating its climate. Without the Gulf Stream, the climate of Western Europe would be much colder, significantly affecting the weather patterns and living conditions in the region. Another famous current is the Kuroshio Current. This current is equally important and influential in the Pacific Ocean, often called the Black Current because of its dark indigo color. It is a warm current in the North Pacific Ocean. The Kuroshio Current is known for its deep blue waters and its role in transporting warm water northward. It flows northward along the east coast of Asia, similar to the Gulf Stream's path in the Atlantic. The Kuroshio Current influences the climate and marine life along the coasts of Japan, Taiwan, and the Philippines. These are just two examples of the many currents that crisscross our oceans. Each of these currents has its own unique characteristics and plays a vital role in the Earth's oceanic system. Each current plays a unique role in shaping our planet's climate and ecosystems. They help distribute heat from the equator to the poles, support marine biodiversity, and influence weather patterns. Understanding these currents is essential for predicting climate change and protecting marine environments. Section 5. Currents and Climate and Intimate Dance. Ocean currents are the Earth's climate control system. They distribute heat from the tropics to the poles, regulating global temperatures. Without these currents, the equator would be much hotter, and the poles would be much colder. Warm currents like the Gulf Stream and the Kuroshio Current bring warm water and air to higher latitudes, moderating coastal climates and influencing weather patterns. For example, the Gulf Stream helps to keep the climate of Western Europe relatively mild, even though it is located at a high latitude. Cold currents, on the other hand, bring cool water from the poles towards the equator, helping to cool these regions. This exchange of heat between the tropics and the poles is crucial for maintaining a stable global climate. Section 6. Oases of Life. The Impact on Marine Life. The oceans are a vast and mysterious world, teeming with life and activity. Ocean currents are not just important for climate, they are also vital for marine life. These currents act as the lifeblood of the ocean, circulating water and nutrients across the globe. They act like conveyor belts, transporting nutrients and oxygen throughout the oceans. This continuous movement ensures that even the most remote parts of the ocean receive the essential elements needed to sustain life. This process supports a vast array of marine ecosystems. From the smallest plankton to the largest whales, every creature in the ocean depends on these currents in some way. Upwelling currents, for example, bring nutrient-rich water from the deep ocean to the surface. This phenomenon is crucial for the productivity of marine environments. These nutrients fuel the growth of phytoplankton, which form the base of the marine food web. Phytoplankton are tiny, but they play a massive role in the ocean's ecosystem. Areas where upwelling occurs are often teeming with life, supporting large populations of fish, birds, and marine mammals. These regions become hotspots of biodiversity and activity. Currents also play a role in the distribution of marine species. They help to spread organisms across vast distances, ensuring genetic diversity and healthy populations. Many marine organisms, from tiny plankton to large whales, rely on currents for transportation. This movement is essential for feeding, breeding, and migration. Currents can carry larvae and juveniles to new habitats, helping to maintain healthy populations. This natural dispersal mechanism is vital for the survival and growth of marine species, ensuring that new generations can thrive in suitable environments. Section 7. Troubled Waters. Currents in a Changing World. Climate change is impacting ocean currents in significant ways. As global temperatures rise, the ocean is absorbing a vast amount of this excess heat. This is altering the temperature and salinity of ocean water, which in turn affects the density-driven circulation of deep ocean currents. Melting glaciers and ice sheets are also adding fresh water to the oceans, further disrupting the delicate balance of salinity that drives these currents. These changes can have profound impacts on global climate patterns, weather events, and marine ecosystems. Understanding how climate change is impacting ocean currents is crucial for predicting future climate scenarios and developing strategies to mitigate the negative consequences. Section 8. The Power of Knowledge. Our role in protecting the currents. We now stand at a critical juncture. The future of our oceans, and indeed our planet, depends on the choices we make today. We must act swiftly and decisively to address the challenges facing our oceans, including the impacts of climate change on ocean currents. Reducing our carbon footprint is paramount. By transitioning to cleaner energy sources, improving energy efficiency, and supporting sustainable practices, we can mitigate the effects of climate change on ocean currents and marine ecosystems. Protecting marine habitats is also essential. Establishing marine protected areas, reducing pollution, and promoting sustainable fishing practices can help to ensure the health and resilience of our oceans in the face of a changing climate. Section 9. A Blue Future. Living in Harmony with Our Oceans. The ocean's currents are a powerful reminder of the interconnectedness of our planet. They demonstrate that what happens in one part of the world can have ripple effects across the globe. By understanding and respecting these powerful forces, we can help to ensure a healthy and vibrant future for our oceans and for generations to come. Let us embrace a future where we live in harmony with our oceans, recognizing their immense value and working together to protect them. The fate of our oceans is in our hands. Let us choose wisely,